All right. Okay. Well, welcome to the Exam 2 review session. So just a few announcements. Well, you know the exam opens up tomorrow, so there's that. Quiz 6 got a bit of an extension. You guys might have seen in the course-wide email. Did anyone not see that? Yeah, check your email. It was from the course coordinator, so make sure to check your email about that. Basically, some people had some issues trying to access the quiz on Wednesday night, so people are getting an extension because of it. So basically, that's the gist of it. So there's that. There's I think there's a quiz sometime in the near future, but we'll cross that bridge later. Basically, there's that. Zoom office hours tonight from 6 to 8. So nice little bit of an extension for office hours if you have any last minute questions. But I don't know, that's basically it really. Okay, so now that we have that taken care of, who has questions on anything related to exam 2?
The second to last question from the homework was due tonight. Can you go through that?
Yes, we can. Once I get to on Kappa, Purdue. So the second to last homework, the one that's due tonight. Come on, you can do it. I believe in you. Sorry, I'm waiting for the one Kappa to do its thing. It's yeah. All right. So homework 18, second to last. This one? Okay. I think we did something very similar to this last time, I think. So we can go over it right quick, but that's kind of something we did last time. So for now, let's see. We have g prime of we have g of x with g prime of x equal to e to the 5x times 2x squared minus 30. So the goal is we have to find the largest open intervals on which f of x increases / decreases, and finds relative extrema. Okay, so let's go ahead and go over this right quick. So step 1. So in this case, we have this function whose derivative is given by this expression that is defined everywhere on the real line, right? What's that? Okay, sorry. So in this case, all we have to do now is just find the critical points to be able to work with it here. So we have 2x squared minus 30 is equal to, if we set this equal to 0, what values of x give us this equality to be true? Well, I'm going to ask her because she asked questions, so I'm going to help her out a bit. So, what values of x give us this equality here? We sort of take a page from what we did last time. So, we can factor out a 2 from both of these terms, right? So we have 2 times e to the 5x times x squared minus 15, right? So we know that e to the 5x, that's never 0. So the only thing we care about here is this x squared minus 15, right? So if we set this equal to 0, what two values of x give us?
Would that be just the square root of 15?
And,
Negative square root of 15?
yep, so plus or minus square root of 15, right? So those are going to be your two critical points. So now step 2 is now we just have to draw our number line. So we got g prime. This is, we're going to have negative root 15 here and positive root 15 here. So like we had yesterday, all we really need to do now is just, focus on our three intervals. You have negative infinity to negative 15, negative root 15 to positive root 15, and then root 15 to infinity. All right? So let's go ahead and start plugging in points from each of these intervals to see what sign we get for each of them. Right? So what would you want to plug in from this interval here to get some behavior about it? And I'm asking anyone here. So.
-4.
Yeah, -4, right? Because the nice thing is that root 16 is, well, negative root 16 is just below negative root 15. So that means that we can plug in -4. And then similarly, we can also plug in g prime of positive 4 for this interval here. Okay? And then in this case, well, you should be able to pretty quickly see that 0 is inside this interval, so we can plug in 0 here to get the behavior of this interval, this middle one. So if we do that, we get, all right, so if we plug in -4 into g prime of x here, what sign do we get? Positive or negative? Would we get negative? If we plug in -4 into here, we get positive, right? Okay. And in a similar fashion, you should also get something positive here. And then what about g prime of 0? Negative, right? Okay. So as a result, you have, so you have a bunch of stuff that's positive. So increasing here, and decreasing here. Okay? So what that should tell you is that this is an increasing interval, and so is this one. And the middle one is decreasing. Okay? So as a result, what should that tell you about relative minimum and relative maximum if we apply the first derivative test? Okay. So by the first derivative test, there's a relative minimum at x equals what? Anyone can answer this one.
Root 15?
Yep, positive root 15, and then by process of elimination, relative max at negative root 15. Okay. Okay.
So like when we got the -4 is 4, why didn't you plug it into the whole thing and not like you only plugged it into x squared minus 15?
Right, because the thing is this is always positive, right? So in this case, that doesn't really contribute to any positive or negative factors here because this is just always positive, so we don't really care about it too much here. So the only way we can get any possible negative factors out of this is we plug this into the quadratic here. Okay. So any questions on that? All right. So, any other questions on anything exam related you want to look at?
Can you do one of those ladder problems?
Oh,
The
but,
leading against the wall.
sure. We can do that. Okay, so we can do that one. Anyone else have any requests? So related rates.
It's similar to hers, one with like a trig function in it.
Oh, like angle of elevation or something?
Yeah.
Okay.
Maybe one of the triangles, go with the angle and not the three sides.
The, what? Can you repeat that?
Like where they gives us an angle instead of the three sides.
Yeah, sure. Like, so basically kind of like what he was talking about?
Yeah.
Okay. So 2 requests for angle of elevation. Anyone else? Alright, well, we'll start with that and then I have some more problems that we can do after that. So, okay, so what we'll do in response to that is we will just go over some examples we did in class for lesson 16. Okay. Alright, so for this one, let's do the latter one. Okay, so the premise is that we have a ladder square root of 8 meters long, rests on horizontal ground, rests, and leans against a vertical wall. So basically our picture kind of looks like this. Okay, so here's the wall, and here's the ground. And our ladder is right here. That's square root of 8 meters long. Okay? So then the foot of the ladder is pulled away from the wall at rates of 0.7 meters per second. How fast is the top sliding down the wall when the foot of the ladder is 2 meters from the wall? Okay, so basically, this was basically just one of the examples from lesson 16, like basically verbatim. So I'm just gonna do it as a quick little overview here. So with a problem like this, we have, here's our wall, here's our ground. So what we'll do is we'll denote this length here by z, corresponding to the ladder, and the distance from the ground to the top of the ladder, the vertical distance, we'll denote that by y, and the horizontal distance from the wall to the bottom of the ladder is denoted by x. Okay, so in this case, what we have is we have a right triangle, which you'll notice, and the nice thing is that there are no angles involved here. So in this case, the formula we should use is going to end up being x squared plus y squared equals z squared. So step 1, if you remember, that was the one where we had to identify the needed formula. So that's step 1 in this case. Okay. Now if you remember step 2, we had to say, all right, of these 3 variables here, which of them were constant and which of them vary with time t? So you could probably pretty quickly figure out that of the 3, well, z is constant, because that always corresponds to the ladder of fixed length. So that's equal to root 8. So while the other 2 vary with time t. Okay. So now from this, we have to sort of take a look at what we're given and then what we need to find from this. Okay? So given and find. Okay, so like we said, we already used this square root of 8 part, so that's already taken care of. We don't care about that anymore. So what we need to focus on is now we're sort of focusing on this point, specific point in time. Specific points in time. Okay. So at this specific point in time, what else are we given? So we have this 0.07 and 2 as our data here. So in this case, if we take a look at these two and look at the problem says the foot of the ladder is being pulled away from the wall at a rate of 0.7 meters per second. So what that says is that we have this little guy here that's taking the bottom of the ladder and moving it to the right at a rate of 0.7 meters per second. So as a result, what quantity would this 0.7 correspond to? dx dt, right? Equals 0.7. Okay. So now how fast is the top sliding down the wall when the foot of the ladder is 2 meters from the wall? So using this sentence here, you should be able to pretty quickly see that, well, I was going to say what was 2, but I guess I kind of already said it. But in this case, since x corresponds to the distance from the horizontal distance from the wall to the foot of the ladder, x is 2. So that means we need to find what?
dy dt.
Yeah, you need to find dy dt. Okay, so that's our. So now we need to find dy dt at this specific point in time. Okay. So now the nice thing is that with z constants, we can just translate this equation here to x squared plus y squared equals 8. Because square root of 8 squared is 8, so that gives us this. Okay, so now if we differentiate this equation here with respect to time t, what should we get as our differentiated equation if we differentiate this with respect to t? So remember, in this case, we treat x and y as differentiable functions of t here. Okay? So if you recall, what that basically tells us is that, all right, so if we were to differentiate, say, f of some function x with respect to t, then what chain rule tells us is that, all right, that's just, you take the derivative of f of x like you normally would, but then because of chain rule, you got to multiply in dx dt after that. And then a similar formula holds if we replace these x's here with y's. Okay. So taking this into account, if we wanted to differentiate, say, x squared with respect to t, using this formula here yields us what? Sorry. Let's give someone else a chance. Go ahead.
2x, x 50, is that one?
Yeah, so 2x is f prime.
Yeah, so 2x dx dt plus 1, 2y dy dt.
Right.
Equals 0.
Yep. So then this is the derivative of x squared, and then doing a similar thing with y, it just yields 2y times dy dt. And then because 8's always constant, that's just a big fat 0. Okay? So now the nice thing is that, well, we have x, we have dx dt, and we need to find dy dt. But, oh wait a minute, we don't have y though. So how do you think we could get that? Any ideas / recollections from lesson 16? Go ahead.
Pythagorean theorem. So it would be 2 squared plus, square root of 8 squared minus 2 squared.
Yep. Yeah. Yeah. So in this case, we have to plug this back into our equation back up here to get y. So in this case, if we have x equals 2 at this particular point in time, we have 2 squared plus y squared equals 8. So that should pretty quickly tell you that y is just, well, 8. Square root of 8 minus 2 squared, so 4. So that's 8, so square root of 4, so just 2. Alright? So 5, all we have to do now is just plug in these values to get what we need. So 2 times x, which is 2, times dx dt, which is 0.7, plus 2 times y, which is 2, then times dy dt equals 0. So a little bit of algebra later should then pretty quickly tell you that dy dt is equal to what?
Negative 0.7.
Negative 0.7. Okay. Alright, and that's the latter example. So any questions on that? Okay, so what we'll do now is we will go ahead and basically do the angle of elevation problem from lesson 16 now. So, let's see, do I have that? I do, excellent. Okay, so the premise is that we have, you see a UFO flying away at a speed of 450 miles per hour at an altitude of 4 miles. So we're focusing on part 2 here. So we find the rate at which the angle of elevation decreases when the angle is pi over 6. So here's what we need. So in this case, if we go ahead and label all the things in our picture here, so we let x be the ground again. So in this case, the x corresponds to the distance between the radar and the point on the ground above where the UFO is above it. The y is the altitude, and then z is the actual distance between the radar and the UFO. Okay? And then we will go ahead and denote theta here by our corresponding angle of elevation. So in this case, what that says is, alright, so theta, we got x, we got y, and we got z. Okay? So we got to find the rate at which the angle of elevation decreases when the angle is pi over 6. So in a situation like this, well, it's not immediately obvious which formula to use here. So need trig. So for now, we're just going to hold off until we have some more information. Okay. So step 2. So of these 4 variables here, which of them are constant and which remain, well, which are varying with time t? So what the problem states is that the UFO is flying away at a speed of at a constant altitude of 4 miles. So what should that 4 here correspond to?
Y.
Yeah, just y, right? So y is constant. Equals 4. Okay? So that tells us, well, we're definitely going to need theta here because, well, we have to deal with an angle here. So we have that, and we have to deal with y. So that helps us narrow down at least somewhat. But now let's take a look at what we're given at a specific point in time. So if we have to find the rate at which the angle decreases when said angle is pi over 6, well, that should pretty quickly tell you that theta has to be pi over 6 here. And so there's that. And then we also have that the UFO is flying away at this speed of 450 miles per hour. So that should tell you that 450 corresponds to which rate?
dx
Yep, dx dt. Okay. And then, of course, the problem says we need to find the rate at which the angle decreases. So that should pretty quickly tell you d theta dt is what we got to find here. Okay? So here's what this says. So we have an angle here, but then we also have that we're given y, and we have to deal with dx dt. So that should pretty quickly tell you that we have to deal with x, y, and theta here. So of the trig equations, which trig equation uses x, y, and theta? So if we harken back to SOHCAHTOA, then which of the trig equations, sine, cosine, or tangent, uses x, y, and theta?
Tangent?
Tangent, right. So we have to deal with tangent of theta equals y over x, but the nice thing is that, well, y is always 4 over x. So what this tells us is that essentially we have that 4x to the negative 1 is equal to tangent of theta. So that's going to be our function which we need to differentiate ultimately. Okay? So from this, let's see what we can establish. So now step 4, if we differentiate this equation here with respect to t, well, what should we end up with here? So we have d over dt of 4x to the negative 1 equals tangent of theta. So now here we assume that x and theta are both differentiable functions of t. So if we employ the same trick that we did in the latter example, then what should we end up with as our differentiated equation here? So let's start with the left-hand side. If we differentiate this with respect to time t, then what should we end up with as our derivative? So again, this is where I'm going to bring back the one rule we had earlier. So if we apply this rule again to 4x to the negative first, then what would we get as our left-hand side?
Negative 4x and negative 2 dx over dt.
Yep. Negative 4x to the negative 2 times dx over dt. And then do a similar thing with tangent of theta to get what?
Negative secant squared theta.
Where are we getting negative though?
I can't see the sign in front of the tangent.
What's it?
The sign in front of the tangent.
Oh, that's an equals.
Oh, okay, so just secant squared theta.
Secant squared theta times
D theta over dt.
yep, times d theta dt. So yeah, this is an equal sign. So let me make that a bit clearer. There we go. Okay, is that better? Okay. So now, in this case, we have, all right, we have dx dt, we have d theta dt, and, well, we have theta, so ultimately we can find secant squared of theta. So the last thing we got to figure out is, well, what the heck is this x thing here? So if we rewrite this just a little bit, we have negative 4 over x squared times dx dt equals secant squared of theta times d theta dt. Okay, so now that we have that, we say, all right, well, if you want to figure out what x is at this particular point in time, well, it's probably a good idea to utilize a similar thing that we did in the last example and plug in theta into our original equation here. So find x. So if we have 4 over x equals tangent of pi over 6, then, remind me, what does tangent of pi over 6 equal? We harken back to our unit circle.
1 over root 3.
1 over root 3, right. So we have 4 over x equals 1 over root 3. So utilizing this equation here should tell you after a bit of algebra that x equals what? Yep, 4 root 3. Okay? Okay, so now that we have that, we can say, all right, now let's go ahead and plug everything in. So we have negative 4 over 4 root 3 colon squared times dx dt, so that's 450, equals secant of pi over 6 squared times d theta dt. Okay? So now let's go ahead and plug everybody in and see what we get out of this. So, I'm going to pull this down a bit. Okay, so now let's go ahead and plug everything in. So what we notice is that, all right, well, we have on the left-hand side, we have negative 4 times 450 over, well, 4 root 3 squared, so that's just 16 times 3 in squaring both of these factors here. And then we have on the right-hand side, we have secant of pi over 6 quantity squared. So, remind me, what is secant of pi over 6 again? Let's take a step back. What's cosine of pi over 6? Root 3 over 2. So that means that, all right, so if this is, so that means secant is 1 over cosine, so that means we have 2 over root 3 quantity squared. So ultimately we have 4/3 on the right-hand side, if we square this, times d theta dt. Okay? So as a result of this, we can say, all right, well, we have a 4 factor on top and bottom, on the top on both sides here, so we can cancel those out. And then we have a 3 on the denominator of both sides, so we can factor those out or cancel those out as well. So ultimately, we're just left with d theta dt equals negative 450 over 16. Okay. So that is going to be your answer for this problem. Okay. So any questions on that? Okay. So let's see, what else do we have? Okay, so here's what we'll do. So does anyone else have any other questions that they want to look at? Because if not, I have some examples that might be worthwhile to look at. So here's what we're going to do. Where are my... There you are. All right, so let's consider another example. So what we're going to do is we're going to do another bit more of a complicated chain rule style problem. So if y equals natural log of the 5th root of, let's see, 2x minus 1 divided by x to the 4th plus e to the x squared. We're going to get crazy with this. Find y prime. So one thing I'm going to give as a hint here, I can't guarantee this will happen on the exam, but as a hint here, I will say hint, use log properties when possible. Okay? So, to see what I mean by this, let's go ahead and take a look at said properties. That's what I'm talking about. So we have natural log of a times b is natural log of a plus natural log of b. Natural log of a divided by b is natural log of a minus natural log b. Natural log of a to the power of b is b times natural log of a. And the derivative of natural log of x is just 1 over x. So here's what happens with this. So if we utilize these properties here, it might help to do that so that way we don't have to deal with, finding essentially the fifth root of all this, because that would be quite disgusting, and I don't want to do that either. So let's go ahead and use our log properties here to break this up. So what we notice right off the bat is that all this entire fraction over here is under the fifth roots. So if we use the corresponding property, what can we do about this fifth root over here?
Be 1/5 natural log.
Yep.
Of all that.
Yep, 1/5 times natural log of all this. So 2x minus 1 over x to the fourth plus e to the x squared. Okay? So then what we notice after this is, well, we have natural log of some fraction. So as a result, we should be able to pretty quickly see that this is 1/5 times what?
Natural log of 2x minus 1 minus natural log of, or 1/5 natural log of x to the fourth plus 3x squared.
Yep, the x squared. Okay, and the thing is that these are both terms at this point have a sum/difference in them, so this is the best we can do regarding breaking things up. Okay? So now at this point, the only thing we really can do is just go ahead and differentiate this. So at this point, we say, all right, so that means we got to figure out the derivative of natural log of 2x minus 1, and then the natural log of x to the fourth plus e to the x squared. Because the thing is that we can differentiate this term by term, and then the 1/5 is constant, so we can just sort of consider that after the fact. So we have, what I mean is that we have 1/5 times the derivative of natural log of 2x minus 1 minus 1/5 times the derivative d over dx of natural log of x to the fourth plus e to the x squared. Okay? So let's take a look at this. So if we were to differentiate this part, then what will we get as our derivative?
Over 2x minus 1.
Yep, 2 over 2x minus 1. Good. 2 over 2x minus 1. Okay. Because all you're really doing is essentially just applying this property up here in junction with chain rule. Okay. And then if we do a similar thing with this term here, well, what you'll notice is that we have x to the fourth plus e to the x squared on the denominator. But then, as a result, you'll see that the numerator is going to be the derivative of x to the fourth plus e to the x squared. So ultimately, what you should be able to quickly see from this is that we have 1/5 times 2 over 2x minus 1 minus 1/5 and times x to the fourth plus e to the x squared. And then the numerator is going to be what? So it would be 4x cubed and then plus what? What would be the second term of the
2x, I mean 4x cubed plus 2x cubed x squared.
Yep. Times plus 2x e to the x squared. Okay. And that's that example. So I just want to do a quick little chain rule one because I'm not sure what kind of chain rule stuff you'll see on the exam, so I figured do a bit of a trickier one just to see you guys you get sort of a idea of what kind of things could show up on the exam. So any questions on this problem? I know this is pretty involved, but I figured cover as many bases as we can.
How do we get the 2 in the numerator in the first term when we took the derivative?
So the numerator here?
Yeah.
Because in this case, all we're doing is we're saying, okay, so if we apply sort of our chain rule roadmap, then the inner function is just 2x minus 1. F of x is natural log of x, right? So if we differentiate this, we get, well, f prime of x is, well, 1 over x, as we just established here. But then we need f prime of g of x for the chain rule. So we have to replace x here with whatever g of x is, which in this case is just 2x minus 1. And then, of course, g prime is just 2, so you just have to multiply these two to get the thing you want. Okay. Is there any other questions on that? Okay. Let's see. Here's what I want to do. I want to do an implicit differentiation problem, so here's what we will do. So the next example, find the slope of the tangent line to y times sine of 2x equals x times cosine of 2y at pi over 2, comma pi over 4. Okay, so in this case, what we have to do is say, all right, what this says is that for a problem like this where you have y and x, that should pretty quickly tell you that you're going to have to use implicit differentiation here. Because in this case, there's no like, oh, find this moment in time or find d whatever over dt. It's just you have y, you have x, that's it. There's no t involved. So in this case, you have to find dy over dx. And in this case, you have to evaluate the derivative dy dx at pi over 2, comma pi over 4. Okay? So in this case, we're going to need that. In this case, we're going to need that rule that we mentioned earlier, this one here, except now we're not differentiating with respect to t, we're going to be differentiating with respect to x. And here we're going to, so we're going to have a similar formula, but just variables are going to be labeled differently. So what I mean is that we have d over dx of f of y equals f prime of y times dy over dx. So that's the rule I'm trying to get at with this. So basically it's similar structure as this, but just with different variables labeled around. So, okay. Okay, so taking that into account, let's go ahead and differentiate this equation here to first get our slope. Okay, so if we do that, we say, all right, well, we're going to have to differentiate this whole thing with respect to x. So what happens if we do that? So we have d over dx of y times sine of 2x equals d over dx times of x times cosine of 2y. All right? So what you'll notice is that, oh, wait a minute, we have y, which is one function of x, times sine of 2x, which is another function of x on the left-hand side. Then we have x, which is a function of x, obviously. And then we have cosine of 2y, which is, again, another function of x. So what you'll notice is that we're going to need product rule on both sides here. Okay? So if we do that, we say, all right, well, that means if we differentiate this if we focus on the left-hand side first, then what do we get as our derivative? Well, applying the product rule says that we have d over dx of y times sine of 2x plus y times d over dx of sine of 2x. Okay? So that's just focusing on the left-hand side first. So if we simplify this down a bit, well, d over dx of y is just what? First off. What's that? Well, then times, yeah. So in this case, we ultimately get dy dx times sine of 2x and then plus y times what? Derivative of sine 2x, which we have already, well, I shouldn't say we already found, but it's similar as to what we saw before in a previous lesson. So, derivative of sine of 2x is what?
2 cosine of 2x.
Yep, 2 times cosine 2x. Okay. So that's the left-hand side. Then if we do a similar thing with the right-hand side, if we apply product rule in a similar way, well, what should we get as our derivative with respect to x there? If we apply the product rule on that.
Cosine 2y plus negative 2x sine 2y.
So plus x times, what was it?
Times negative 2 sine 2y.
Yep, 2y times,
Deal with it.
yep, dy dx. Because remember, this is, because this part here is still, you differentiate this like you normally do, but then multiply dy dx into there. Okay? So this is the left-hand side, this is the right-hand side. So ultimately what this says is that you have dy dx plus 2y times cosine of, yeah, wait, sorry, I've got a factor there. So dy dx times sine of 2x plus 2y times cosine of 2x equals cosine of 2y minus 2x x sine of 2y times dy over dx. Okay? Now, at this point you're thinking, okay, well, now we have to solve for dy dx, right? Well, you could, but this is going to be kind of a bit of an involving thing to solve for dy dx here. So you could solve for dy dx, but in this case, if you just need the slope, as we mentioned in the implicit differentiation lesson, sometimes it's better to plug in the point first, then solve for dy dx. So that's exactly what we're going to do here. So x equals pi over 2, y equals pi over 4. So we have dy over dx times sine of, well, 2 times pi over 2, so just pi, and then plus 2 times pi over 4 times cosine of 2x, so in this case pi again, and then we have cosine of 2y, so cosine of pi over 2. Yep. And then minus 2 times x, which is pi over 2, times sine of 2 times y, so pi over 2, times dy over dx. Okay? So then, if we utilize our unit circle here, what simplifies and or cancels out here? Well, sine of pi, well, if we recall from the unit circle, that's just what? Big fat 0. And what you'll notice is that cosine of pi over 2 is also 0. And then we have cosine of pi, if you recall, is just negative 1. So then 2 times pi over 4, that's pi over 2. So that equals negative 2 times pi over 2, so that's pi. Then times sine of pi over 2, that's 1. So ultimately, you have negative pi over 2 equals negative pi dy dx. So that should pretty quickly tell you from that, you just have a big fat 1/2. Okay?
I thought y was pi over 4. Because like after the equals, you cosine pi over 2. Was it cosine 2y?
Where at? Here?
Yeah.
What?
Next equation. Like you put cosine pi over 2. I thought you plugged in pi over 4 for y.
The left-hand side we have sine of 2x though.
Oh, okay.
Yeah.
Thanks.
Okay. Any other questions on that? Alright, well, that's all I had for review then. So like I said, Zoom office hours tonight. Make sure you do the extra credit when you get the chance. Other than that, that's all I really had. So so I'll see you guys either in office hours tonight. Otherwise, I will see you guys next week, and good luck on the exam.
We don't have class on Monday, right?
Yeah, no class on Monday.